Hello ladies, in this video we're going to go through 5D difficult questions. So 5D is composite shapes. I've left here the theory that you would have seen in 5C just because you also need it for 5D and it's easier for me to refer back to if it's in this document as well. So just so you're not sitting there thinking, oh, is this 5C? It isn't, it is 5D. All right, so 5D focuses on composite shapes. I've mentioned composite shapes before. So basically you don't have a regular shape, it's a shape that is composed of more than one shape. So you can see here in question 5, we've got, first of all, some rectangles with a triangle or a parallelogram. We've got some circles with a circle inside or a triangle inside, and we need to use our knowledge of area to work out the shaded area of the shape. Okay, so question says, and I'm just going to make sure I'm doing it correctly, find the area of the shaded region, okay, so the blue region, by subtracting the area of the clear shape from the total area. And we're going to round our answers to one decimal place. So I'm just going to scroll until we can't see that. Okay. Now, question A. Let me just redraw it. Now, I need to redraw it because if I draw in here, it's going to make things go weird. And I'm going to use different colors. So we have our outer shape, and we all know I'm really good at drawing diagrams. Okay, it is a rectangle. It's a rectangle with a length of 10 and a width of 18. So the area of that shape or a rectangle is length times width. So we're just multiplying our length times our width, which gives us 180. Okay, so that's the rectangle. Now let's just change the color because I can. And then we've got a triangle inside it. Kind of looks like a wonky elf's hat. Okay. Now, when you're doing the area of a triangle, there is actually more than one formula for the area of a triangle, but in Year 9, we're just going to be using a half base times height. So our base, you can see from the diagram, is 18, and the height is 10 because your triangle goes straight from the base all the way to the top of the rectangle. So your height is 18. So our area, if we just oops, not 18, sorry, is 10. So it's just going to be half times 10 times 18. And I did get them around the wrong way, but because we're multiplying, it doesn't really matter. All right, then we've already done 10 times 18. We know that's 180, and then divided by a half, sorry, multiplied by a half or divided by 2 gives you 90. You can also use your calculator if you need to, but make sure when you're doing this sort of work that you do show you're working out, because sometimes your mistake is in your working out. And if you don't show it, then as a teacher, I don't know where you've made the mistake. Okay, so the shaded area is just going to be the rectangle, which is 180, minus the triangle, which is 90. So your shaded area is 90 and our units centimeters squared. All right, so let's move on. Now I could do the other two, but because I'm running out of room, I'm just going to scroll down and I might do question E. Okay, so I'm going to draw the larger circle in red. And when you're given a circle, you're usually given either the radius or the diameter. So remember, the radius is just from the center of the circle to the outside, and in this case, the radius is 1.7. Okay, so we're just dealing with that one now. Just ignore that smaller circle. So the area of the circle is pi r squared, and that's going to be pi r is 1.7 squared. Now you could do that at this point in your calculator, but it's a good habit to get into to not do your rounding until the very end. So I'm going to just leave it as that for now. And I'm going to just get my green. Okay, so our smaller circle, okay, so you can see that one in there. It's a bit hard to see, but the radius, there is a dotted line going down, is 0.6. Okay, so the area formula is the same, pi r squared, and we're just substituting in for our radius, which is 0.6. Okay, I'm going to leave that. I'm not going to do the calculation just yet. So your shaded area is going to be pi times 1.7 squared minus pi times 0.6 squared. And I'll just quickly do that in my calculator. Actually, I might pause it while I do that. You don't need to watch. All right, it's always a good idea to also check that you've written it in your calculator correctly, which I have. I think we're doing it to 1 decimal place, so that gives us 7.9. And what are we dealing with? Meters, so meters squared. Okay, so if you got a different decimal place, it could be because you rounded earlier, but I strongly encourage you to wait until the very end to do your rounding. All right, I'm going to do question F as well, just because it's a little bit different. And we'll just do some scrolling. So we have, first of all, a circle. I want to get the red pen, thank you. Another awesome circle. Okay, so our circle has a radius of 9.01. So I'll just do the area of that. So area is pi r squared. Notice how I'm writing the formula. That's just good because it'll cement in your memory a lot easier if you write it down. And as before, I'm just going to leave it in its exact form for now. And then we had a triangle inside. So we've got a triangle that has a, now it's a bit hard to see because it's drawn on its side, but our base is 10. And because it's a right angle, and you can only do this if it was a right angle, your height is 15. Okay, so your base is 10 and your height is 15. So we have a right angle triangle, and I'm going to draw it around the right way up. So it's a right angle triangle, and we have 10 and 15 on our sides. So area of a triangle is a half base times height. So it's a half times 10 times 15. Now, if you're doing this in your head, do your larger numbers first. So 10 times 15 is 150. And then when you multiply that by a half, which is the same as dividing by 2, you get 75. All right, so our shaded area is our circle, which is pi times 9.01 squared minus 75. And I'll just quickly do that on my calculator. And I get 180.0. Now try to get into the habit of putting those zeros on the end, okay, because it did say 1 decimal place, and that is 1 decimal place. So even though it's the same as 180, it's a good habit to get it into, to put it to 1 decimal place. Okay, and if you're sitting there wondering why I didn't do this one to 1 decimal place, because it is a whole number, whereas F is not a whole number. You actually got it to decimal places. Okay, so we're just working in centimeters, just looking for the unit, so centimeters squared. All right, with the other shapes, I might just go through them instead of doing them. B, you've got a rectangle, 9 and 5, and you can do this 2 ways. You've got basically 2 triangles that are the same. Okay, so you can work out the area of the triangles if you like, or you have a parallelogram in the middle. Okay, so you can work out the area of that. And if we just scroll up, you can get your, oh sorry, trapezium. I always get them mixed up. So we've got a trapezium and we've got a parallelogram. So trapezium, and then the next one we've got a parallelogram. Okay, so the outside shape is a parallelogram, and then we've got a triangle in the middle. Here we have a rectangle inside a rectangle. Okay, so you need to use your knowledge of the shapes to do that. Now, actually, it's a square. So you see how these two lines, we've got these two lines. So each side is 3.3. It just doesn't look like a square. Okay, we'll move on. Also, remember in your online textbook, you have work solutions. So if you're ever unsure, refer to them. Sometimes it helps break things down for you. All right, question 6. An area of lawn is made up of a rectangle measuring 10 by 15. Okay, so I'm going to do my rectangle. Another great rectangle. 10 by 15. And a semicircle of radius 5. So we're going to add a semicircle on the end. Okay, so it looks like that. And it has a radius of 5. So I could have actually drawn that semicircle up the top here. It was just by chance that I did it here and it was actually the right side because it says the radius is 5. So it has to go on this end with the 10 because the radius is half of 10. Whereas if I put it here, the radius of the semicircle would be half of 15, which wouldn't be correct. Okay, so find the total area of lawn. Okay, so let's break the shapes up separately. We have a rectangle first of all, which is 10 and 15. So we'll do the area of that first. So 150. And then we have a semicircle. And it has a radius of 5. So your area of a semicircle. Now, if you've got a full circle, it's pi r squared. And if you've got half a circle or a semicircle, it says pi r squared divided by 2 because we only want half of it. All right, and we'll just substitute the 5 in. So 5 squared over 2. And then we add the 2 together. So the total area is 150 plus, you can simplify this if you want. So 5 squared is 25. So 25 pi over 2. But at this point, you can just plug it into your calculator. You've probably shown enough working out that you understand how the formulas work. Okay, I'm just making sure it's in my calculator correctly. We're doing it to 2 decimal places. So I get 189.27. And what are we dealing with? Meters. So meters squared. All right, let's scroll on. Question 9. So these shapes include sectors. Find their area correct to 1 decimal place. Okay, so let's do A first of all. So we're going to break the shape up. Let's break it into the rectangle first. And that is, so this whole side, oh, this one's a difficult one, is 24. And this, oh, I didn't know I could draw on there. I'm actually drawing on the diagram. Okay. And this side here, you're probably thinking, oh, well, what is it? Okay, and this side here is 18. So when I draw my rectangle, I know this side is 18, but I don't know yet what this side is. So that's going to take you a little bit of problem solving. Now this distance, okay, is the same as this distance here, which is the same as this distance here, okay? And it's just the radius of that semicircle, well, not the semicircle, that sector. And it's just a quarter of a circle. So we can work that out by saying, all right, this distance is just 24, the whole distance there, minus this here, which is 18. And that's going to be 6. So your radius of this quarter circle is 6, which makes this also 6. So this side is 6, the area of your rectangle, length times width, 18 times 6. What is that, 96? No, not 96, 108. And I'm just going to check that on my calculator because I would hate to do something wrong and my calculator's just died on me. I'm going to use my phone. Okay, good. And then the area of this sector. So you can use a sector formula, but it is a quarter of a circle. And I'll just scroll down so we've got a bit more room. Okay, so there is a right angle in there. Your radius is 6, which you calculated before. So the area of a whole circle is pi r squared, but we're only dealing with a quarter, so we can just divide that by 4. Now, dividing by 4 is the same as if you use the sector formula. Whoops. Okay, because that's 1/4. All right, so the same thing. You can use either the sector formula or realize that this is a quarter of a circle. So we've got pi times 6 squared over 4. And I'm just going to scroll up a bit. So I'm just going to write 36 pi on 4. Now, obviously, you can simplify that. I'm not going to because I've shown enough working. I'm just going to go straight to the total area. So the area of your rectangle plus the area of that quarter circle. And do that on your calculator. Now, my actual calculator's, the battery has died, so I'm going to just have to use my phone. I might pause for a sec. Okay, and I get 136, and it was 2 decimal places, I think, so 0.27, and just going to scroll up to see what we're working with. Oh, it's to 1 decimal place. Okay, so to 1 decimal place, 136.3 centimeters squared. All right, now looking at the other shapes. Now, I'm not going to do the whole working out. Okay, I'm just going to draw the 2 shapes for you. So this one here, we've got a rectangle. So sometimes that's the easier one to spot. Okay, and a 7 and a 3. And then we've got a sector. Oh gosh. Great sector. Now, this angle here, remember what we call theta in our sector formula, is this angle here. Okay, so that's theta. Now, if I know this whole angle is 140, then theta is equal to 140 minus, and there's a right angle there. Okay, so think about your right angle in that rectangle. So we're going to take away 90, and that gives us 50 degrees. So your angle here is 50. So when you're doing your sector formula, so the area of a sector is theta over 360 times pi r squared. You're going to have 50 over 360 times pi times r, so your radius, and the radius is the same as the length of the rectangle, which is 7. Okay, so hopefully that's enough information for you to do question B. Now, question C, again, I'll just do the 2 shapes. We kind of have like, I won't say it's a full Pac-Man. But, sorry, my neighbor is just calling me and it distracted me, but I might just let it go. So we have 11 here. Okay, so the radius is 11. Now, you can use the sector formula, or you can say, well, that's 3/4 of a circle. So you can multiply the area formula by 3/4 is exactly the same thing. So if we're doing theta, that angle is just 3/4 of a circle. Oops, 3/4 of 360. So remember, a full circle is 360. So 3/4 of 360 is 270. So that angle there is 270. So your area of the sector is 270 over 360, which is the same as 3/4. Remember I said you could just do 3/4 of a circle, times pi times 11 squared. And then you've got this triangle here. So your triangle, got the right angle there, which is important because if it wasn't a right angle triangle, we can't assume that this is the height. So our base is 11 because this is the radius and this is also the radius. This side here is also 11. And remember, your area formula is half base times height. So you just need to add those two together. All right, moving on. Oh, 20 minutes already. Now, I was a bit reluctant to put this one in, but I thought I would because even though there's a diagram, it is a bit of a tricky question. So a new car manufacturer is designing a logo. It's in the shape of a diamond inside a rectangle. The diamond is to have a horizontal width of 3 centimeters. So you can see that there, 3 centimeters, and an area equal to 1/6. So this is important. I just realized I can draw on these diagrams of the area of the rectangle. Find the required height of the diamond. So let's first of all work out the area of the diamond. Okay, so to work out the area of the diamond, we know it's 1/6 of the area of the rectangle. Okay, so I underlined that in the question. 1/6 of the area of the rectangle. So the area of the rectangle is 12 times 6. Oh gosh, testing my memory of my multiplication, 72. So 1/6 of that is going to be 1/6 times 72, which is 12. Okay, so the area of the diamond, don't have to write the whole thing, it's going to be 12 centimeters squared. All right, then we got to work out the height of the diamond. So I'm going to just scroll back up to our formulas and hopefully it's on our formula sheet. Okay, so diamond, we've got the height here. Okay, so we can use that. So it's half times x times y. So I'm going to go back down, half xy. Scroll, 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 scroll. Okay, so your area formula is a half times x times y. So basically, we know the area has to be 12. We know the width of the diamond is 3, and the height is what we're working out. So I'm just going to leave that as h, and then we can solve for h. So a half times 3 is 1.5. And then divide both sides by 1.5. That disappears. Now, you're probably thinking, oh, it's not good to divide by a decimal, and it's not, but we're just calculating something here, so it's all good. All right, I'm just getting my phone out again. Okay, so 12 divided by 1.5 gives us 8. So the height of the diamond is 8, and we're working in centimeters, so 8 centimeters. And I think that was the last question. Yes, good stuff. Bye, ladies.